Hi. In this session, let us look at trigonometric identities. We have already looked at trigonometric ratios and also ratios of complementary angles. So trigonometric ratios, as you all know, it is sin theta, cos theta, tan theta, cosecant theta, secant theta and cot theta. And sin theta is opposite by hypotenuse, cos is adjacent by hypotenuse, tan is opposite by adjacent. So we know these, and also we know what is the relationship between trigonometric ratios having complementary angles. That is sin theta equals cos 90 minus theta, secant theta equals cosecant 90 minus theta, tan theta equals cot 90 minus theta, and you can also reverse the order and write them. Cos theta equals sin 90 minus theta, cosecant theta equals secant 90 minus theta, and cot theta equals tan 90 minus theta. Now, having known all these, now let's move on to another important part, that those are the trigonometric identities. We'll be looking at three main trigonometric identities and their variations. The first one is sin squared theta plus cos squared theta equals 1. So sin squared theta plus cos squared theta is equal to 1. So shall we prove that first? So taking the left hand side, what is sin theta? Sin theta is opposite by hypotenuse, that is AB by AC. So sin squared theta would be AB squared by AC squared. Similarly, cos theta would be adjacent by hypotenuse, that is BC squared by AC squared. So BC squared by AC squared. So now the denominator is the same, AC squared, let's write that, and the numerator is AB square plus BC square. We know this is a right angle triangle, and we know the Pythagoras theorem, according to which hypotenuse square, that is AC square, equals AB square plus BC square. So AB square plus BC square is AC square. So substituting that, we have AC squared by AC square, which is equal to 1. So we got the right hand side. So we have the clear understanding how this has come about. So the first important identity is sin squared theta plus cos squared theta equals 1. And the variations of these, taking the sin that side, sin squared that side, I can write it as 1 minus sin squared theta equals cos squared theta. Or if I take the cos square to one side along with 1, I can write 1 minus cos square theta equals sin square theta. Now let's go on to the second identity. The second identity is one plus tan squared theta equals secant square theta. Now let's take the left hand side and try to prove this. 1 plus tan squared theta. So 1 plus, what is tan theta? Tan theta is opposite by adjacent. So opposite is AB, adjacent BC. So AB square by BC square. So 1 plus AB square by BC square. So now let's take the LCM as BC square. Now BC, 1 into BC square plus AB square. And we know AB squared plus BC squared equals AC squared by Pythagoras theorem. So AC squared by BC squared. And we know that secant theta equals hypotenuse by adjacent. So AC by BC. So this is secant theta and there is a square, so I can write this as secant square theta. So we have reached the right hand side. So 1 plus tan squared theta equals secant squared theta. So let's write this over here. 1 plus tan squared theta equals secant squared theta. The variations are secant squared theta minus 1 equals tan squared theta, and secant squared theta minus tan squared theta equals 1. So these are the variations. So this is the second identity. Now what is the third one? I think you should be able to guess using the second one. 1 plus cot squared theta equals cosecant square theta. Now let's take the left hand side and try to prove this. This is 1 plus, what is cot theta? Adjacent by opposite. So BC square by AB square. Now let's take the LCM, AB square, and I get AB square plus BC square. AB square plus BC square is AC squared according to the Pythagoras theorem. So I have AC squared by AB square. So I can write this as AC by AB whole square. Now AC by AB is nothing but cosecant theta. Cosecant theta is equal to hypotenuse by opposite. So this can be written as cosecant squared theta. So now this is proved. This is the third one. So the third one is 1 plus cot square theta equals cosecant squared theta, and cosecant squared theta minus 1 equals cot squared theta, and the last one is cosecant squared theta minus cot squared theta equals 1. So I hope you understood the three identities and the variations of each of those, because you need to keep them in mind. They should be at your fingertips, because when you do proving problems using prove something is equal to something else, these identities will come in very handy and you will be able to do your problems much faster. Okay, I hope you understood. Please go through them, revise them. In my next session I will be doing a lot of problems related to identities and also some of the earlier types. Thank you.